So that is mostly what I am doing in my research. I take sediment cores like the ones that I showed you from Lake Malawi and try to understand the hydrological cycle. Lake Malawi is actually a really cool example because that gray blob of sediment that's in the core on the right that you have there in that handout was deposited during what we call a mega drought. This is again a sort of confusing term, a way that geologists are confusing everyone. When meteorologists say mega drought, they mean the 1930s Dust Bowl, right? When we say mega drought, we mean something that lasted 10,000 years or longer, really, really long. That's why the level of Lake Malawi was able to drop so incredibly low. So aside from generally cooler conditions and generally drier, it turns out my research and other people's research has shown that rainfall didn't just kind of decrease. It didn't just sort of gradually let up. There's actually a massive reorganization of the way that the atmosphere circulates around Africa at that time. And in fact, this was a tropics-wide phenomenon that was really interesting that we still don't know a whole lot about. But it pushed, there's a major belt of rainfall that migrates around in the tropics. It pushed that around. It changed the amount of rainfall. It changed the timing of rainfall. It changed all kinds of things. And those are finally the things that a farmer sitting in a village in East Africa actually starts to care about, right? We also know from other cores, from other places, I also work in Indonesia, and there's a particular lake I've been working on there that shows that during the peak of the last ice age, CO2 was low. It was actually pretty dry at the site, quite dry. The rainforest was actually entirely replaced, not entirely replaced. Much of the rainforest was replaced with grassland. So it was really, really dry. But at the same time, we have evidence now that monsoon circulation was intensified at that time, which is really counterintuitive, because usually we think stronger monsoon circulation, more rain, right? That was not the case in Indonesia during the last glacial maximum. And it's actually kind of an interesting counter corollary, or I'm not sure what you would call it, for what's projected for the future. There are regions of the tropics where monsoon circulation, the intensity, the vigorousness of circulation is projected to increase or projected to decrease, while actual rainfall is projected to increase. So kind of counterintuitive, but it turns out that when we start looking at these questions with paleoclimate, we can actually bring some really interesting results to the table.